Let's take a look at some examples of equations that will have infinitely many solutions. So here's our first example of an equation that will have infinitely many solutions, and just by looking at it right now, it's hard to tell that it's going to have infinitely many solutions, just because there's some simplifying that we need to do first. There's these parentheses here, which tells me that I need to use the distributive property. So let's use the distributive property and solve this equation so you can see what it looks like when we have infinitely many solutions. So distributive property means everything inside the parentheses gets multiplied by 3. So this side stays the same. And then we do 3 times 2a. So 3 times 2 is 6a. And then 3 times a negative 1. 3 times negative 1 is negative 3. Okay, so this is the equation that we're working with. Now, it might look kind of interesting to you so far, but let's keep solving so you can see what it looks like. Let's get all of our variables on this side, so that means our variable is a this time, so we want all of the a's on this side, and we want all of the constants on this side. Okay, so that means this 6a is not in the right place. It needs to go away. So we combine it with its 0 pair, and do the same thing on both sides to keep things balanced. 6a minus 6a is 0, so we don't have to write anything for that, but we do still have a negative 3 on this side. Then we have 6a minus 6a is 0, but we still have the negative 3. Okay, now we're left with negative 3 equals negative 3. If I were to continue trying to move all the constants on this side, I would want this negative 3 to move. It's on the wrong side, so I would add 3 on both sides. And when I do that, I have a negative 3 and positive 3 is 0. Negative 3 and positive 3 is 0. So I end up with the statement 0 equals 0, which is true, right? 0 does equal 0. But when I end up with a statement like this, it tells me that this equation has infinitely many solutions. In other words, there's infinitely many numbers that I could plug in for a to have this equation be true. So if we remember what it looked like at this point, it was 6a minus 3 and then 6a minus 3. Obviously, we have the same thing on both sides of the equation. So no matter what we put in for a right here, it's going to be the same thing when we put in an a right here. We'll get the same result on both sides, no matter what number we choose for a. So when we have the same variable term on both sides and the same constant term on both sides, then that means our equation has infinitely many solutions. We don't even need to solve it all the way. We can just look at it like at this point and decide that there will be infinitely many solutions. Let's take a look at one more. Okay, so this one, it's hard to tell by looking at it that it has infinitely many solutions because there's some distribution that we need to do. So let's do that and then we'll maybe get a clearer picture of what it is. So we need to distribute this 2, so everything gets multiplied by 2. So we have 2 times 3a is 6a, and 2 times a negative 12 is negative 24. Okay, this is equal to, now we have to distribute this 3 over here. 3 times 2a is 6a, and then 3 times a negative 8 is negative 24. So notice, once we do our simplifying and use the distributive property here, we see that we have the same expression on both sides of the equal sign. And so when we have the same thing, we have the same variable and we have the same constant, that means our equation will have infinitely many solutions. Okay, move on to the last video where I go over examples of equations with one solution.